Hi, I'm Lance Cooper with SOR. In this presentation, I will review the form, fit, function, features, and benefits of the 815PT Smart Pressure Transmitter. The 815PT is an explosion-proof pressure transmitter designed for use in hazardous locations and hostile environments. It has a compact footprint that is less than 6.1 inches long and less than 1.4 inches wide. This small footprint makes it ideally suited for installation in tight spaces. It goes without saying, but is worth noting, the 815PT is a best-in-class stick transmitter. All model number configurations provide as standard the following outputs and communication capability. The popular 4 to 20 milliamp and the 1 to 5 volt DC low power mode of operation outputs, a configurable solid state switch output. This is a single pole, single throw, normally open relay that is rated for 30 volts DC and 120 milliamps. HART 7 communications protocol and Modbus RTU serial communications. By the way, the communication capability of the 815PT enables it to be configured with a HART handheld communicator, a HART modem with software, and with Modbus software and computer interface. Also, the zero and span set points can be easily set with a magnet. The magnetic targets are located on the housing. One important caveat: the 815PT is not compatible with the SOR calibration kit, which is used with the 805PT and 805QS to change settings in the field. Now let's take a closer look at certain specifications. The 815PT has an accuracy of plus minus 0.1% upper range limit or full scale output. It is available in 12 pressure ranges. The lowest pressure range is 0 to 5 psi and the highest is 0 to 30,000 psi. All ranges have a 5 to 1 turn down. So, low pressures between 0 and 1 psi can be accurately measured using the 0 to 5 psi unit, whereas high pressure applications, such as offshore oil and gas wells, can be tackled with the 0 to 30,000 psi unit. Note that the 815 has an exceptional response time that is less than or equal to 70 milliseconds and is designed for use with process temperatures ranging between minus 40 to 90 degrees Celsius. Other important specifications are: the 815 comes standard with hermetically sealed 72-inch long color-coded flying leads. Even though the 815's housing is constructed of 3/16 stainless steel, it weighs only 1.8 pounds. Standard wetted materials are made of either 3/16 or 17/4 stainless steel, and to demonstrate the confidence that SOR has in the quality of our products, we back the 815 with a 3-year warranty. Let's do a quick comparative analysis of the Series 800 family of pressure transmitters. As you can see, all three provide a 4 to 20 milliamp and a 1 to 5 volt DC outputs. Both outputs are standard with the 815PT. However, with the 805PT and the 805QS, the output must be specified in the model number. Let's take a look at an example. An 805 PTC provides only a 4 to 20 milliamp output, and a 805 PTV provides only a 1 to 5 volt DC output. The same applies to the 805 QS. Note that only the 815 and the 805 QS provide a switch output. Both switches are a single pole, single throw, normally open, solid state relay that is rated 30 volts DC and 120 milliamps. One significant difference is that the switch output of the 815 can be configured 9 ways, whereas the switch on the 805 QS has only 3 configurations. Various unique features are offered only by the 815. Those are HART protocol and Modbus RTU serial communications, the external zero-span magnetic targets that are located on the housing. This enables one to set the zero and span points with a magnet. Lower and higher pressure ranges, and a better accuracy of plus minus 0.1% upper range limit or full scale output. Alright, it is time to take a closer look at the functionality of the programmable switch output of the 815. Here we go. While it is possible to configure the switch output of the 815 PT 9 distinct ways, the most widely used switch options are the windowed and single point configurations. Other possible switch functions include pulse width modulation or PWM and deadband control capability. PWM and deadband functionality enables the customer to address other unique applications. To better understand the windowed functionality of the 815 PT's switch output, consider the following example of the windowed, normally closed option, or the lower diagram. In this mode, the switch output is closed when the process pressure is within a user selectable range and open when the pressure is outside of these boundaries. For example, the window could be set for an acceptable operating range of 50 psi to 150 psi. That is to say, the low set point is 50 psi and the high set point is 150 psi. The switch will be closed or on when the pressure being monitored is between 50 and 150 psi. If the pressure goes below 50 psi or above 150 psi, the switch will open or turn off. This particular switch functionality makes the 815 well suited for wellhead pump control and shutdown, where the 4 to 20 milliamp signal can be the primary input to a pumping unit, and the switch output can serve as an emergency failsafe device. The upper diagram is just the opposite of the lower diagram. The easiest way to understand the single point, normally open switch functionality is to use the following terminology: close on rise, open on fall. So at 0% pressure, the switch is open or off. It remains open until the pressure rises to the set point, at which time it closes or turns on, and remains closed until the pressure decreases or falls back to the set point, at which time the switch returns to its normally open condition. So the switch is normally open and closes when the process pressure rises, and opens again when the process returns to a pressure at or below the set point. You can see that the lower diagram is just the opposite of the upper diagram. The single point, normally closed switch functionality is best understood using the terminology open on rise, close on fall. In this case, at 0% pressure, the switch is closed or on. It remains closed until the pressure rises to the set point, at which time it opens or turns off, and remains open until the pressure decreases or falls back to the set point, at which time the switch returns to its normally closed condition. So the switch is normally closed and opens when the process pressure rises, and closes again when the process returns to a pressure at or below the set point. The next couple of slides emphasize the proper way to install the 815 PT. The first step in the installation process is to make the process connection. Avoid the use of a pipe wrench, monkey wrench, channel lock, vice grip, or similar tools on the 815's housing. Use of these tools could damage the nameplate or the external ground lug. SOR recommends using 2 open-end wrenches. Use one wrench to hold the process fitting and another 1 1/8 inch open-end wrench at the hex flat on the process connection to tighten the 815. The 815 PT can be connected to rigid or flexible pipe or tubing. Just make sure that the process piping system is adequately supported. The final step in the installation process is the electrical connection. As noted on the previous slide, it is important to avoid the use of a pipe wrench, monkey wrench, channel lock, vice grip, or similar style tools on the 815's housing. The 815 has a high quality, laser etched, 26 gauge stainless steel nameplate or tag that could be damaged or separated from the housing by these tools. Furthermore, the very important external ground lug could be damaged as well. SOR recommends using a 1 1/8 inch open-end wrench on the flats of the electrical connection when tightening the conduit pipe or fitting. The open-end wrench provides a counterforce to prevent the 815 from rotating when the conduit pipe or fitting is being securely connected. The 815 PT can be connected to rigid or flexible electrical conduit or mounted into an unthreaded knockout hole using an appropriate lock nut. Make sure that the conduit system used is adequately supported. Now that we've completed the installation of the 815 PT, it is time to wire the instrument for the desired output. All variants or flavors of the 815 PT Smart Pressure Transmitter will have 8 color-coded insulated conductors or wires, also known as flying leads. The 8 colors are, in alphabetical order, black, blue, brown, green, orange, red, yellow, and white. All 8 conductors do not need to be terminated or wired. It is okay to use only the wires that are required for your specific application. For example, if one does not need the configurable solid-state switch output functionality of the 815 PT, one would simply not terminate the yellow and orange conductors. The same can be said for the brown and white wires. If one does not require Modbus RTU serial communications on an RS485 twisted shielded pair network, then it isn't necessary to terminate the brown and white wires. By the way, and this is very important, do not cut and discard unused conductors. Instead, protect and safeguard all unused conductors for future use of the specific functionality that is available via those conductors. Now let's take a look at the very important red and black wires. Those serve a multi-purpose role. The red and black wires supply power to the 815 PT instrument, or stated another way, the loop voltage is supplied via the red and black wires. The black and red wires are also required for a 4 to 20 milliamp output, and if needed, the HART communication protocol is also superimposed on the red and black wires. One of the most important wires is the green insulated conductor. It is connected to earth ground. A very good earth ground is a solid copper rod driven 3 or more feet into the soil, into the ground. Note that the blue insulated conductor is not shown on this slide. That is because the blue wire is not needed for a 4 to 20 milliamp output. So onward we go to the next slide to see how the blue wire is used. This is the wiring diagram for the 1 to 5 volt DC low power mode of operation. This output is ideally suited for remote applications such as oil and gas well sites where instruments are operated with battery power. Note that the blue insulated conductor is required for a 1 to 5 volt DC output, and if needed, the HART communication protocol is also superimposed on the blue wire. Note that the red and black wires are also required to power the 815 PT instrument. As before, it is not necessary to terminate all 8 conductors. It is okay to terminate only the wires that are required for your specific application. Also recall that one should not cut and discard unused conductors. Instead, protect and safeguard all unused conductors for future use of the specific functionality that is available via those conductors. Always properly ground the 815 PT instrument using the green insulated conductor. The 815 PT offers HART 7 communications protocol and Modbus RTU serial communications. For clarification and increased knowledge, consider the following definitions. HART is an acronym that stands for Highway Addressable Remote Transducer. A HART-enabled instrument like the 815 can send and receive digital information across analog wires to a control or monitoring system. HART communicates at 1200 bits per second over the current loop found in many older plants worldwide. The HART digital signal is superimposed at a low level on the 4 to 20 milliamp analog measurement signal without causing any interference with the analog signal. For more information on HART, go to hartcomm.org. That's HARTCOMM.org. Now let's talk a little bit about Modbus RTU. RTU is an acronym that stands for Remote Terminal Unit. Modbus is often used to connect a supervisory computer or master with an RTU in SCADA systems. SCADA stands for Supervisory Control and Data Acquisition. It is essentially a type of industrial control system. Modbus RTU is a master-slave type system that has one node, the master node, that issues commands to one of the slave nodes and then processes the responses from that slave. Slave nodes will not typically transmit data without a request from the master node and do not communicate with other slaves. A wireless solution is very popular because it minimizes installation cost and reduces the time to install and fully commission a network. Modbus is an ideal protocol for RTU applications where wireless communication is required. For this reason, it is used in many oil and gas and electrical substation applications. But Modbus is not only an industrial protocol, It is also used in commercial buildings, infrastructure, transportation, and energy applications. Therefore, the Modbus RTU capability of the 815 PT opens new market opportunities for SOR. For more information on Modbus, go to modbus.org. That's modbus.org. There are three ways to configure, diagnose, or reconfigure the 815 PT. One may use a HART handheld communicator, or HHC. The HHC is considered a HART master. Another option is to use a computer with HART configuration software and a HART modem. The HART software and modem are readily available from many suppliers. The modem simply plugs into a USB port on any computer. The modem is also considered a HART master. Lastly, any supervisory control system with Modbus configuration software, which could be a laptop and an RS-232 to RS-485 converter module. The Modbus software and converter module are also available from many suppliers, and as with the HART modem, the converter module plugs into a standard USB port. Two important reminders. Number one, the zero and span can be set with a magnet. The circular shaped zero and the triangular shaped span targets are located on the housing just above the nameplate. The second reminder is that the 815 is not compatible with the SOR calibration kit, which is only used with the 805 PT and the 805 QS to change settings in the field. The four device variables outlined in the device definition table represents the data or information that will be provided by the 815 PT via the analog output and the HART digital communication protocol. The primary variable, or PV, is provided via the analog outputs. The other three variables is provided via the HART digital communication protocol. Since the 815 is a pressure transmitter, the value provided by the primary variable is the process pressure, and the default unit is pounds per square inch, or PSI. The secondary variable, or SV, is the temperature in degrees Celsius. However, this is not the process temperature. This is the temperature of the 815 PT's internal electronic components. Since the 815 is a pressure transmitter, not a temperature transmitter, it is incapable of providing the temperature of the process. The SV is provided via HART. The tertiary variable, or TV, monitors or provides the loop voltage in volts. The TV is also provided via HART. Lastly, the fiduciary variable, or FV, is a dynamic or open value. It can be configured by the user to output or provide any available HART value and the desired unit of measure. Like the secondary variable and the tertiary variable, the fiduciary variable is provided via the HART digital communication protocol. On a previous slide, I discussed the different ways to configure, diagnose, and reconfigure an 815 PT smart pressure transmitter. Let's take a closer look at how to connect the HART handheld communicator, or HHC, to the 815 PT to configure the unit for a 4 to 20 milliamp output. Begin by connecting the HHC's lead set to the red and black flying leads on the 815. Connect the HHC's red lead to the 815's red wire and the HHC's black lead to the 815's black wire. So it's pretty straightforward, red to red and black to black. This next step is very critical. It is important to add some resistance, indicated by the load resistor R sub L, into the loop. This resistor must be greater than or equal to 250 ohms. This resistor should be connected to the HHC's black lead, the 815 PT's black wire, and the power supply's negative terminal. The next slide explains why this is necessary. Keep in mind that the pictorial diagram on this slide shows what one would see in a laboratory benchtop setup rather than a plant environment. The encircled capital A represents an ammeter that is used to measure the loop current or output, whereas the rectangular power supply provides power to the 815. It represents the loop voltage. These two pieces of benchtop equipment and the load resistor would not be seen in a real-world plant environment that has a current loop. The prior slide noted the importance of adding at least 250 ohms of resistance to the current loop, indicated by the load resistor R sub L. Sometimes it is difficult to get the HART device to communicate when it's on the benchtop, even though it communicated fine when wired in the field. Oftentimes, when the HART instrument is on the benchtop, the loop does not have enough resistance for the HART signal to be seen by the HART master. Therefore, a minimum loop resistance is needed so that the HART signal can be seen or read by a HART master, such as a HART communicator or HART modem. In a real-world application, that is to say, in a plant environment, the significantly longer length of the plant's current loop provides adequate resistance. On a previous slide, we looked at how to connect the HART handheld communicator, or HHC, to the 815 PT to configure the unit for a 4 to 20 milliamp output. Let's look at how the HHC is connected to the 815 to configure the unit for a 1 to 5 volt DC low power output. Simply connect the HHC's lead set to the blue and black flying leads on the 815. Note that a load resistor R sub L is not required for this output configuration. Also note that the red wire is still required because the red and black wires provide power to the 815 PT. As stated previously, the pictorial diagrams on these slides depict what one would see in a laboratory benchtop setup rather than a plant environment. The encircled capital V represents a voltmeter that is used to measure the low power voltage outputs. The rectangular power supply once again provides power to the 815 PT via the red and black wires. These two pieces of benchtop equipment, as noted before, would not be seen in a real-world plant environment that has a current loop. One significant capability that is offered as standard with every 815 PT smart pressure transmitter is Modbus RTU serial communications. Modbus RTU is an industrial protocol that runs on an industrial network. For this reason, it is used in many oil and gas and electrical substation power generation applications. However, Modbus is not only an industrial protocol, it is also used in commercial buildings, infrastructure, transportation, and energy monitoring and management applications. Typically, Modbus RTU communications is only offered with full-featured process instruments. It is usually not offered in a compact, robust, and economical stick form factor transmitter like the 815 PT, which, by the way, is also HART capable. Let's take a closer look at specific applications. If you need a 4 to 20 milliamp output, select the 815 PT. If you need a 1 to 5 volt DC low power output mode of operation, choose the 815. If you need a discrete solid state switch output that is configurable 9 distinct ways, pick the 815 PT. If your plant has a current loop and your organization is standardized on HART instruments, every 815 PT comes with HART 7 communications protocol that is backward compatible with earlier versions of HART. If your plant has a Modbus RTU network and you need to monitor water pressure, air pressure, hydraulic pressure, steam pressure, or any other process pressure, the 815 PT will fit in those tight, dangerous, hazardous, hostile areas of your plant. The 815 PT's robust, stainless steel, explosion-proof housing has the right stuff. If you need all of the above, well, the 815 PT Smart Pressure Transmitter offers all these features as standard. There is no need to choose. They are readily available for you to use. The 815 PT is designed for your industry. Oil and gas production, pipelines, power generation, petrochemical, refining, chemical and pharmaceutical, and food and beverage, just to name a few. The 815 PT is released to market and available for purchase. For pressure ranges of 10,000 psi or less, the base list is $690 US. The 15,000 psi unit is listed for $828, and the 30,000 psi unit has a list price of $897. This concludes my presentation. Thank you for taking time to view this video. I hope that it was informative and beneficial. 815 documentation is readily available on sorinc.com. My name is Lance Cooper, Product Manager for Pressure and Temperature Instruments at SOR in Lenexa, Kansas. If you require additional information or support, please contact me at 913-956-3091 or 1-800-676-6794. Thank you.